Well, it looks like we're recording. So we're looking at databases here, and I want to talk about select statements. So we're only going to do very simple select statements where you're selecting things out of one table. One of the next lectures will talk about selecting things out of multiple tables, which of course requires a join. I say of course as if you would have any reason to know that it requires a join. The thing that allows you to select things from multiple tables, which will be in a future lecture, is called a join. So here's what we're looking at. Selecting columns from one table, and you're going to choose only rows that match certain criteria. That's basically what you're doing with the select statement on one table. We'll also talk a little bit about setting an alias for the table name and a little bit about the precedence and the where clause. This should be fairly short. There's not too much to go over here. So we've talked about creating databases, creating the schema for a database, managing it with a database management tool, or in the worst case scenario with the command line. And so the question is, how do we get data out of the database? This is a little bit of an ambiguous question. Do we want to find data in the database from within the database, or do we want to do it kind of from a programming language? And before we can think about how we would access the database from a programming language such as Python or Java or PHP or something like that, we need to know what the database's native language is, so to speak. So we're going to first focus on how to get data out of a table from inside the database using the database's native language, which is, of course, SQL. Sometimes people just say SQL. This stands for the Standard Query Language. This is a relational language that deals with sets. This is very different than any other programming language. It's probably most similar to Prolog, but it's not really that similar to any other commonly used programming language. There's of course going to be, now that I say that, I'm sure if you Google it, you'll find like 7 slightly obscure languages that are relational based, and you'll call me a liar or whatever. But generally speaking, SQL is the most popular relational language. It deals with sets. So there's many different statements, operations you can do to a database in SQL, but select is the single most important statement that you really need to understand, because the types of queries you're going to do to your database using SQL determines a lot of the performance and how you want to actually build and structure your database. To some extent, is determined by the types of questions you want to ask. Now, I should note there's a lot of really good database administration tools that can actually handle a lot of the other statements for inserting, creating, altering tables, creating indices or indexes and stuff like that. But the select statement, you really need to understand how that works. So the basic syntax, you're going to have select, then you're going to list the columns you want, you're going to say from, you're going to list the tables you want, you're going to say where, and then you're going to list the conditions that you want. So these are the columns you're selecting, the table you're selecting them from, and the conditions that need to be true in order for that particular row to be added to your result set. So some notes about SQL syntax. The capitalization of keywords is irrelevant, so select in all caps is equivalent to saying select in all lowercase, or any other weird combination, just capitalize the second E or something like that. You use single quotes for strings. This is one of the few languages where a single equal sign actually means equals. It does not mean assignment. In fact, there's not really a lot of ways to do assignment. It doesn't really mean what you think it normally means in a programming language in SQL. And we actually start counting at 1. Most programming languages start counting at 0. SQL is one of the few that actually starts at 1. I think Prolog's another one that actually starts at 1. And actually single equal means equals in Prolog rather than assignment as well, so that's kind of exciting. So suppose we have our actors table. We've got the actor ID, we've got the name, the age, the number of Us Weekly or US Weekly or whatever that tabloid-type magazine is called, appearances. So we've got a bunch of these rows in our database. I'm just going to put one here as an example. You can actually think of that as a set. Apparently sets, I just realized this, look like smushed chocolate chip cookies. So you've got this set, and each thing in here is an actor. Each thing in here is a row of that set. So a simple select statement, you're going to say something like select star from actors. What do you think's going to happen if you do this? Like, what would your guess be? If you're guessing that it's going to give you all the rows from actors and it'll list every column from the actors table, you're correct. We'll get all the rows, and then we'll get all the columns for each row. I have a note here for showing this in phpMyAdmin. I'm actually going to hold off on doing that. I'm going to sort of try to do one big lecture on phpMyAdmin. You may want not everything about an actor. You may only want certain columns. So you could say, okay, well, just give me the name and the age from the actors table. This will give you every row, in other words, every actor in the actors table, but it's only going to give you the name column and the age column. So the number of Us Weekly appearances, maybe there's date of birth, maybe there's, you know, I don't know, current address. You know, not that it would make sense for there to, you know, be a database of actors' addresses, because then, you know, paparazzi could find them, but whatever, there could be a number of other columns. But for this particular query, we're not interested in those. We just want the name and the age of the actor. Now I should note, you can also write it like this. This is called creating a table alias. Select a.name, a.age from actors A. You can also sometimes see this written from actors and then the word as here, as A. That also works. So as long as there's no ambiguity, you don't need to do this. If there's possible ambiguity, which for one table there won't be, but you know, you can always go ahead and do this. You can just sort of say, okay, well, A is the table I'm interested in. That's actors, and so I want a.name and a.age. So this A sort of refers up here to this to these A's. Now, if we only want certain rows, we start applying criteria in what's called a where clause. So select star, so we want all the columns from actors, where, here's a criteria, you only want the ones that are over 30 and have more than 10 Us Weekly appearances. And so this where clause is going to act kind of like a filter. It's going to pick only elements in the set that fit a certain criteria. So when I do this in class, I'll actually draw this as a Venn diagram. I'm going to bounce back a few slides to my little smushed cookie. So you can imagine if this is your set of all actors and we say, okay, give us all the ones with the ages over 30, maybe there's a line that would sort of cut this in half. Maybe these are the 3 that are over 30 and these 5 are under 30. And then there might be some other way of slicing it where it's like, well, these have more than 10 Us Weekly appearances, these have less than 10, so you'd sort of look for the intersection, which would only be maybe these two. So that's kind of what's happening. That's a very formal way to describe it. If you just sort of look at the query, you can kind of see, okay, where the age is greater than 30 and the number of appearances is greater than 10. So here's your first question to try to answer. Are these the same or are these different, based on sort of what you can guess? So select all the columns from the actors table where the number of Us Weeklies is greater than 10 and the number of Us Weeklies is less than 20, so they're sort of from 11 to 19, or the age is greater than 10, versus select all the columns from the actors table where age is greater than 10, or Us Weeklies greater than 10 and Us Weeklies less than 20. So is either the same or different? Go ahead onto Moodle and try that out. So if you're saying same, you're right, the reason being and has a higher precedence than or. So even though we're not putting parentheses here, we may as well, because and has a higher precedence, which means it's binding these, it's going to check these two things first, and then it's going to do or age greater than 10. So these basically are going to be the same thing. So just keep in mind, and or have different precedents. This is the case in really anything that implements Boolean or logical and ors. And if you're not sure, you can always use parentheses to kind of group things as desired. So next question, are these the same or are these different? I'll give you a chance to answer. Did you say same? If so, you're right. These mean the same thing. Here we're just kind of giving actors this alias, this name A, and then we're referring back to it up here. We're not doing that here, but it's okay. We're only selecting from one table, so as long as this table has a column named name and a column named age, we're actually okay. Now, some other notes, just to jump back a little bit, about spacing and capitalization and whatnot. So you notice here I'm doing everything, all my commands like select and where and from. Those are special keywords in SQL. I'm doing these all in lowercase. That's fine. You notice I'm sort of spacing this out. That's fine. I'm actually ending the query with a semicolon. That's typically going to be done. In a lot of contexts that's required. There's actually a lot of context where it's not required, typically if you're entering queries into some web interface. A lot of times it's just going to go ahead and tack that on the end for you. If you're sending queries through a programming language and there's only one, a lot of times the database driver will take care of that for you. So I tend to write these with a semicolon, but it really is going to vary greatly depending on what kind of a local system you are running on. And so what we're going to do in class using this material, I'm going to give you a database schema, and then you're going to write some selects based on this, and we're going to do some clicker questions about some different selects based on the database schema.